Welcome to an example of classifications of functions such as one-one function, on-to function, bijections, and invertible functions. Show that the function f defined from r star to r star by f of x is equal to 1 by x is 1-1 and on-to, where r star is a set of all non-zero real numbers. Is the result true if the domain is replaced by n set of natural numbers with codomain being the same as r star? Let's take the first case. What is this r star? R star is the set of all non-zero real numbers. This is set of real numbers including 0. To make it r star, we need to delete number 0. Now this is set of non-zero real numbers which is named as r star here. And a function is defined from this r star to r star. As the rule given is, for any x that is taken in the domain, the image, the y, will be calculated using this rule. That is, y, the image of x, the f of x is the reciprocal of x, 1 upon x. Let's see whether this function is a one-one function. What is a one-one function? A function f defined from a to b is called one-one function or injective function if distinct elements have distinct images. That is, for any two distinct elements of the domain, the images should also be distinct. That is, whenever x1 and x2 are unequal, whenever x1 and x2 are two numbers of the domain which are unequal, it should imply that their images should also be unequal. Distinct elements should have distinct images. Such a function is called one-one function. In other words, in case the images happen to be equal, for some x1 and x2, if f of x1 and f of x2 happen to be equal, if they are equal, then the x1 and x2 also should be equal. That is, whenever x1 and x2 are unequal, the images should be unequal. In case the images are equal, then the x1 and x2 should also be equal. These are two interpretations of this definition. Two different ways the definition is interpreted. While checking it for any function, any example, we may use either of them. One is, take two distinct elements x1 and x2 unequal and prove that the images are also unequal. Or another method is, start with two equal images and prove that their pre-images x1 and x2 are also equal. Both of them mean the same. Here in this question, let us check. Let us begin with two images which are equal, if possible. Let there be two images f of x1 and f of x2 equal for some x1 and x2 of the domain. That means if f of x1 and f of x2 are equal, we can say f of x1 is 1 by x1, f of x2 is 1 upon x2. So this implies that 1 upon x1 and 1 upon x2 are equal. This is a simple equation from which we can say x1 and x2 must be equal. That means whenever we have f of x1 and f of x2 equal, we could logically prove that the x1 and x2 are also equal in this example. Hence, This proves that this given function follows the second interpretation of this definition. So we conclude that this function is a one-one function. It is a one-one function. Now let's see whether it is an onto function. What is an onto function? Onto function. A function defined from set A to set B is called onto function or surjective function if for each element y taken in the codomain, there exists an element x in the domain such that the image of that x is the y that you have taken. Again, the three stages once more. For each element y taken in the codomain, let's take a y taken in the codomain, there should exist at least one x in A, the domain. There should be an x in A, and that's not enough, such that the image of this x is y. That means f of x, its image should be this y that you have started with. So these three stages are to be followed by this function. Then we can call this function a onto function. Let's begin. Let y be an element, y a representative element of the codomain R star. Take a y. And if possible, let this y be equal to 1 upon x for some x of the domain. We don't know whether this x will belong to this domain. If possible, let us take so. Is it possible? Yet to be checked. So let y be equal to 1 upon x for some x. Now we are going to check whether this kind of an x will really belong to the domain. Will it belong to the domain? That need to be cross-checked. From this equation, I am writing x equal to 1 by y, a simple reciprocal equation from which we can conclude x is equal to 1 upon y. Now, the x we have calculated in terms of the y that we have taken. We need to now check whether the x that we obtain like this, will it really belong to the domain? Is it possible? Let's check. Now, in case the y was the value of y, as we have taken y a representative element from here, in case y is taking the value 0, 1 upon 0 is undefined. So this x undefined value we cannot expect in the domain. But as we know, this y is taken from R star. R star is a set in which 0 is not there. So this y would never be equal to this 0. Hence, for any other number, the reciprocal of non-zero number is x, which is definitely available in this domain. So it is possible. It is possible that the x that we have calculated will belong to the domain. There exists an element in the domain. So for this y, take its reciprocal back, that will be available in this set. This is not enough. One thing more we need to conclude to satisfy the complete definition. We have got an x that is belonging to the domain. Now, will that x have the image this y itself? Or is it satisfying f of x equal to y? Let us check. Calculate f of x. F of x is equal to, in place of x, place 1 by y. F of 1 by y need to be calculated. Go by this rule. F of any number is reciprocal of that number. So f of 1 by y is reciprocal of 1 by y. 1 upon 1 by y, which is equal to y. Yes. Now the third stage also is being concluded. F of x is equal to y. F of x is equal to y. Hence, this whole example is following the definition of onto. Hence, we can conclude that the function is an onto function. A function which is 1, 1 and onto is called a bijection. Here, this example given to us is a bijection. And a bijection is an invertible function and has a unique inverse. A bijection, a function which is 1, 1 as well as onto, is an invertible function and has a unique inverse function. Now, continue with the second part of the question. That is, if the domain is replaced by a set of natural numbers. The domain this time is not R star, only set of natural numbers. That is negative numbers, this part is avoided. And only the integers, positive integers are taken, which is what set of natural numbers. Codomain being the same. Now let's see. Let's cross check the oneness once more. Let f of x1 be equal to f of x2. Two images, let them be equal. Then 1 by x1 equal to 1 by x2. And which implies x1 is equal to x2. Hence the function is 1, 1 because this x1 and x2 are now natural numbers. Even for natural numbers, if 1 upon x1 and 1 upon x2 are equal, x1 will be equal to x2. This is following the definition. Whenever f of x1 is equal to f of x2, that is implying that x1 equal to x2. So the function remains 1, 1. Nothing happened. Even if the domain is changed, there is no problem. The function is still 1, 1 function. Go ahead checking onto function. Remember, this time the domain is having only positive integers. So let us take a y that belongs to the codomain to compare with the definition. Begin with y that belongs to the codomain. Then if possible, let y is equal to 1 by x for some x, which means x is equal to 1 upon y. This x equal to 1 upon y did belong to R star, the domain in earlier case. But remember, this time it is the domain is changed to natural numbers. So this 1 upon y always need not belong to this natural number. For example, in case the y was taken as 5, this y was taken as 5. So the x is 1 upon 5. 1 upon 5 will definitely belong to set of real numbers or this set R star. But 1 upon 5 is not a natural number. So corresponding to the number 5, we are not finding an x here. So we need to mention that here. This will not belong to set of natural number. So we started with if possible let this be so, and we calculated that x and we noticed that it's not possible. Such an x will not belong to natural number set. So no point in continuing with this part. We conclude that this function is not onto. The reason we can highlight just by giving a counter example also. Take y is equal to 5. Then if 5 is equal to 1 upon x, x must be 1 by 5. 1 upon 5 cannot belong to the set of natural numbers. So this definition is violated. Hence this function is not onto once you change the domain into set of natural numbers.